All right, so for this lesson, we're going to go over predicting products. You're going to have three different types of reactions. There's going to be the replacement reactions, single replacement, double replacement, and then there will be combustion, because combustion are the easiest ones to predict products for. All right, so when we're looking at these, if you are going to do a replacement reaction, let me go ahead and get this on the draw feature. If you're going to do a replacement reaction, then you're going to look at whatever is by itself, okay, in a single replacement, and you are going to take that element and you're going to switch it with an element that is the same kind, okay? So zinc is a metal, and it is going to replace the metal in this other reactant. Does that make sense? So a metal can replace another metal because they both have positive charges. A non-metal, I don't think I put any of those in here, but a non-metal will replace a non-metal. I think, and I have not, like, just full disclosure, I haven't looked over all this to make sure I didn't do this, but I don't think I gave you any that are non-metals because that typically threw some people off in the past. So we have zinc, and it's going to replace silver. So what we're going to do is we're going to make our product be, and this is a single replacement because zinc is single, and so you know you're going to have something single over here. Silver is going to be our first reactant that is just by itself because zinc was by itself. Let me go ahead and make little arrows to show you what's happening here. And so we have silver by itself. Remember, if it is a metal, it's just written by itself, no subscript of a 2. Moving on to the product, which is going to be zinc nitrate. So this means we're going to have charges that are going to crisscross, okay? So zinc and nitrate, we're going to assume in this case, if we have a transition metal, every single transition metal except for silver is going to have a charge of a 2, okay? Again, you're going to have to refer up to here to find out what the charge is of the transition metal. Most of them are commonly 2, just to make life easier. We're going to say that they're all a 2, except silver, because silver, this would be something that in AP Chem you'd have to memorize, but silver is always a +1 charge. No exceptions. So that's the one and only transition metal that's always got the same charge. Okay, silver's just strange like that. So nitrate on your polyatomic chart has a charge different than the periodic table. It's a 1. When we switch these, this is going to become Zn parentheses nitrate and then a 2. Okay? So I'm going to pause this real quick and see if y'all have any questions about this one. Okay, so in the next example, I'm going to switch colors here because I need to make sure this is going to look a little different. So in number 2, we have another element that is single. This is going to be a single replacement again. And by the way, your example, your directions tell you that you need to also balance this. So I'm not going to balance that first one for you right now. We're just focusing on predicting products. So we have tin. Tin is a metal. It's also a positive charge. It's going to switch with, in this compound, it's going to switch with the other thing that is a positive charge. However, hydrogen is not a metal. So I think it would be better for me to note that pretty much these are all the first elements switching places because they're both the same charge. They're both positive. It may not be +1 and +1. They may have different charges, but they're both positively charged. You can't have a positive ion replace a negative ion in something and it be stable. If you put 2 positives together, that's not going to work. Okay? So tin and hydrogen are going to switch places. So now when they switch places, do the arrows help? Or can you do this without me drawing the arrows? Okay. So hydrogen's going to be by itself. We're going to write it first. Does this blue even show up back there? Kind of hard to see. Right. So just making sure. I know in the video it's like really bright right now. Okay, there we go. So for hydrogen by itself, Is hydrogen a metal or a non-metal? It is a non-metal. Be really careful about hydrogen because it's H2, not just H. Okay? And then we're going to put tin with chloride. So remember, if it is a transition metal, letter tin also included in that, then its charge, we're going to assume for making this easier, is always a +2. So tin is going to have a +2 charge, and then we have chloride. So it has a charge of 1. When we switch their charges, we have SnCl2. Okay? It's not that bad. I need to go over another type of reaction with y'all, so I'm going to do number 3 with y'all. Okay, this is a 2-sided worksheet, so don't think I'm doing like all 10, and then you don't have to do anything. So number 3, we're going to look at copper. So it's always the first elements. We're going to look at copper, and we're going to look at magnesium. They're just switching partners. So now we're going to have magnesium nitrate and copper chloride. So Mg is going to be with NO3. And then I would switch my charges. Let's see. Mg has a charge of what, y'all? It's a 2. Nitrate has a charge of a 1. When we write that formula, then it's going to be, bless you, it's going to be Mg parentheses NO3 and then the 2. And then we're going to put copper with chlorine. By the way, let me pause real quick here and just let you know if magnesium is replacing copper, we always write the metal first. So this isn't going to be NO3 with Mg. It's going to be NO3 written second and Mg comes first. Okay? So again, don't write it like, hey, I'm just going to put these two together and these two together, but I'm just going to write it in this order because this one was on the left here. It's the metal comes first, then the non-metal component. So I don't know if me explaining that made it seem more confusing or if that makes sense, but the metal's always written first, then the non-metal part. So it's magnesium nitrate, not nitrate with magnesium. And then we're going to put copper and chlorine together. So copper, transition metal, it's going to have a charge of a 2 here, and then chlorine has a charge of a 1. When we switch those, it's CuCl2. So these pretty much look the same as they did on the other side. We just switched copper and magnesium. Everything else worked out perfectly. Okay? All right, thumbs up if y'all are, this is making sense. It'll take some practice. Okay, what I think is probably the easiest example is a combustion. Do y'all remember, oh, by the way, this is a double replacement. Do y'all remember what products you're always going to have for a combustion?
H2.
Yes. Good, Christian and Spencer. Water and H2O. So maybe that's on the back. All right, so we're going to look on the back at number 4. And if you didn't copy that previous example, I can come back to it. So number 4 on the back is a combustion. So anytime for this particular exercise, anytime you see oxygen as a reactant with some kind of hydrocarbon, honestly, if you just see something with oxygen as a reactant, that is going to be a combustion. And your products are always CO2 plus H2O, always. And there's always a test A and a test B. I know at least one of the 2 versions of the test has a combustion where you predict the products. I think they both do. I think I tried to make sure it was pretty even. All right. So, do y'all have, let me go ahead and pause. Okay, so y'all are just going to work on practice now, and if you have any questions, let me know. Remember, if you have a single or a double replacement, it's always the first elements, both of the metals, are going to switch partners. And then if you have a combustion, and those are only on the back, you're looking for oxygen as a reactant, and it's going to form carbon dioxide and water. Okay?